Okay, we're doing our first simulation, and it's using a website that is from the University of Colorado, and they have some wonderful simulations for physics and chemistry and biology and whatnot. So you'll be familiar with this site by the end of the course. And so when you go to this page over here, you'll see that we get our website, and you're going to hit the click to run. Whoops. And you'll get to the a screen that looks like this. All right. And if you follow the instruction, there's all kinds of text as far as what we're trying to get you to understand with this assignment is the difference between velocity and speed and distance and displacement. While very often they can mean the same thing, there are times when there's a difference, and the difference is pretty substantial. Velocity and displacement are what we call vectors. And what that means is the way that you go, the direction that you travel is going to matter. And so for the first time, you're going to see terms that have negative signs in front of them. And that's going to be important that you realize that, okay, whether I'm going to the left or right matters. All right, the very first thing that you're asked to do is come over here, and where you see this tab that says charts, hit that, and you'll see that we have a place to graph the motion man's motion, but we want to eliminate, for the first example, we want to get rid of the velocity and the acceleration graph so that it just looks like this. And you can play around with this and see that, let's graph this as we move our motion man, and as he comes backwards, and if he goes fast or slow. You can take a look at different examples of what's happening to him. And this is simply graphing it, and at this point right here you can see that he's not moving anywhere, and so it stops. All right, so I'm just going to hit stop, and I'm there. Now you'll then be asked to, let's go ahead and reset this, because we're going to go back. So it says reset, and I want to reset all. But again, the next, I don't want the acceleration. I do want the velocity and position graphs, but I don't want the acceleration. But let's play around this and just take a look at this. Now this is 0. This is just some frame of reference that we're arbitrarily choosing. So we're just going to say there, this is, you're at the starting place, if you will. Now look at what happens if I go into this box, and in this text box, I'm going to type in 5. And can you predict where the motion man will be placed if I put in 5? Now notice that if I place 5, he's closer to the house. If instead I put a -5 in, now all of a sudden he's closer to the tree, because the direction that we move him does matter, whether he's closer to the tree or whether he's closer to the house. All right, let's go ahead and put his position back to 0. And this time, let's go ahead and put in a velocity. So let's say that I'm going to put him at 2 meters per second. That's the speed that I want him to travel. And I'm going to hit the play button. And as I hit the play button, you can see that his motion is being graphed. Now you've done enough assignments. All right, we hit the wall. So now let's take a look at this. And does this position time graph make sense to you? Does it seem reasonable that it's a diagonal line and that the slope of that line is positive? Also, take a look at the velocity time graph. Does this make sense to you, that the velocity time graph for these first about 5 seconds, it stays horizontal? Why do you think it stays at the same exact value this whole time? What's happening to it? Why would it stay horizontal? Now, let's compare that to if I have him go, let's reset. And again, I want to get rid of the acceleration. This time, let's have him go at a negative, let's make him 0.5 meters per second. Now, making a negative sign, what do you think that's going to do with his motion? So let's go ahead and test it and see what happens. And so now I'm going to hit the play button and take a look at what's happening. Why is it going so much slower? And what do you notice is different between the position time graphs and the velocity time graphs in the example that we did before? And does it make sense? All right, now let's stop this for a second. And notice, do you notice anything different about this? It's still a diagonal, but do you see how it's not a positive diagonal, it's a negative diagonal? And now look at this right here. It's closer to the 0, but it's not at the 0 because he is moving, he's just moving slowly. Now think about these with all the assignments and activities that you've done. Do these graphs make sense? Good luck!